Welcome to Algebra 2, Unit 1, Lesson 4. As with the last couple of lessons, this is a redone version of the original Lesson 4. Again, just me trying to break down the material into a way that's going to hopefully make it easier for you to get your head around and to feel confident. As always, communicate with me about questions that you have and let me know what I can be doing better so that you're able to follow along with the lessons more easily. So this lesson in class is going to start with an explore / warm up, a little activity to get you going and get you thinking in the channels that will be conducive to this particular lesson. But I also want you to be creative. And I know we started the year with this idea of describe to me a time when you were wrong about something. And the idea behind that assignment was to try to change how we think about being wrong. So when you're working on an explore, that's exactly what I want you to do, to explore, to just be curious, to look at, use the tools that you have and play around with it. Now, before we can do this particular explore, we do need to be really clear about a particular definition, and that is this definition right here. What is the solution to an equation? Now, a lot of you might say, well, the solution to an equation is the answer, and that's a little vague. So how do you know when you've arrived at the answer? What is it about, say, the number 4 that makes it right, but the number 5 is wrong? Like there has to be something about the number 4 that makes that number the answer, not just like any old number. And so to go over what is the solution here, the solution to an equation, any equation. Notice it doesn't say a linear equation or absolute value equation or anything. It's just what is the solution to an equation? Any equation. It is the value or values, because there can be more than one, of the variable that make the equation true. So you can pause the video and write that down if you are watching from home. Just kind of take a moment and let that sink in. All right, so it's the values of the variable that make the equation true. Now, in that, there's actually more vocabulary. I think we're probably okay with variable. I think most of you guys know that that is some quantity in the equation that can change. And it's often represented by a letter. I think you're okay with equations. Equations have to have an equal sign. Now, what might not be as straightforward is true. So what does it mean for an equation to be true? Because if you're looking for the values of the variable that make an equation true, you have to know when an equation is true. An equation that's true, we don't want to overthink this, is something like 5 equals 5. I think everybody would agree that's true. 5 equals 5. Or -2 equals -2. Or 0 equals 0, or 1.2 equals 1.2. Okay, all of those are examples of true statements, as opposed to a false statement. A false statement might be something like 2 equals 3. Okay, that is a false statement. All of these over here are true statements. 2 equals 3 is a false statement. So what you're looking for is you're looking for variables that when you put them in to your equation here, so you, oh, whoops, I wanted my pointer turned on. There we go. Oh, there we go. So when you plug them in, you'll get something like 5 equals 5, or -2 equals -2, or something like that. Okay, it could be anything. You could even be something like y equals y, although we want to be a little bit careful with that. Okay, so here is your explore / warm up. So work alone or with a group of 2 or 3. I very rarely will tell students that they have to work with somebody in the class, though a lot of times it's beneficial. But I know some students really don't want to do it, and so I don't usually make you. So a group with a group of 2 or 3, no bigger than 3, because once we get bigger than 3 students, then it starts to turn to, one person is doing it and 2 people are having a sidebar conversation and 1 person's taking a nap. Okay, so we want to keep the groups fairly small. So 2 or 3 to explore the following equations. Try to find the solution or solutions using any method except looking it up online or via app or website. So I know you can take your phone and snap a photo of it, and your phone will tell you the answer. That's not what we're trying to do here. We want to explore and handle this. So here are some things that you might try. You might try guess and check. So pick a number and see if it works. Then pick another number and see if you're closer or further from it working, and then see if you can home in on a particular solution. You could try graphing. Hop on over to Desmos. You might say, well, Ms. Taylor, I don't know what to graph. Try something. Okay, talk about it with a partner. Say, what if we graph this? What if we graph that? Let's just see what happens. You could try to solve it algebraically. I think most of you could solve the equation without the absolute value. So maybe try that and see what happens, and then see what kind of questions arise. Now, show your work neatly for each attempt, even if it is unsuccessful. Label each attempt as attempt 1, attempt 2, etc. So if you try one thing and it doesn't work, or you're not sure if it worked, go ahead and try something else, and just on your paper, label it. Remember, we're not afraid of getting stuff wrong. We're not afraid of having an unsuccessful attempt. The goal of this is simply for you to explore and engage some of your strategies and just see how they work. If you're doing this from home, take some time, pause the video, and try to do this on your own. The plan in class is to allow about 5 to 10 minutes for groups and individuals to tinker around with this and to see what they're able to come up with. So that would be a good amount of time for you to budget if you're doing this from home. All right, so now let's explore this in more detail. What is absolute value? We've talked about it a little bit. We've been using absolute value functions. I know for one of the lessons, we filled out a table with some absolute values in it. It is important that we know what absolute value is if we're going to be handling absolute value in equations. Now, keep in mind the symbol for absolute value is 2 vertical lines, and in between those vertical lines you have some stuff. Okay, so we use a very high level vocabulary word there. Stuff, some math stuff you've got in between the 2 vertical lines. Make sure the vertical lines do not look like ones. Okay, so if you saw something like this, you might be unsure as to whether that was 151 or the absolute value of 5. So make sure that your absolute values look a little different. So the definition of absolute value is the distance of a number from 0 on the number line. Number lines are so important. That is messy. Let's see if we can clean that up. There we go. Okay, so for example, we have there the absolute value of 3, and then we have the absolute value of -3. So we look at our number line, okay, and we'll just hang on. That is not how the number line works. There we go. Okay, so I don't know why I started that at -5, but here's your 0. Okay, that's the center of your number line right there. And you would, on your number line, say find the number 3, okay, which is out here. And what you're looking for is that distance right there. Now, I've had students ask some really good questions at this point, like, Ms. Taylor, are we counting the number of lines, or are we counting the number of spaces? And we are counting the number of spaces. So how many units do I have to travel to get from the 3 to the 0? I have to go 1 unit, 2 units, 3 units. Okay, and so the absolute value of 3 is 3. On the other side of this, we have the negative 3 right there. Okay, and absolute value is defined as distance. So we are looking for that distance right there. And so it's how far do I have to travel? 1 unit, 2 units, 3 units. Oops, didn't quite click on that. There we go. Okay, now it's important to note there that there are actually two numbers that have an absolute value of 3. That would be the 3 and the negative 3. Keep that in mind. That's going to become very important when we're dealing with the equations. Now, I have a little aside down at the bottom of the screen there. Definitions can seem boring or unimportant. It's very easy for us to gloss over definitions. We just don't want to deal with them. But knowing what we mean when we use certain words is crucial to understanding directions or being able to ask good questions. So it's important when something says solve the absolute value or find the absolute value of whatever, that you know what that means, because that is empowering. Knowing your vocabulary also can help you to ask questions. And most of you have had at some point the experience of trying to ask a question and then not being able to pull the right word out. So not being able to say numerator or denominator or radicand or x-axis or x-coordinate or x-intercept, which are all different things. And if you use the wrong word, if you say x-axis when what you mean is x-intercept, then your question doesn't make sense to the person you're asking it to, and you don't get the answer that you're looking for. So I know vocabulary can be dry, but it's so important. All right, now we can apply the definition to solve equations. All right, so one of the reasons we need to know that definition of absolute value is so that we can use the definition to reason our way through the equations, through the problems. So consider this very simple equation. The absolute value of x equals 4. Okay, very simple equation. The value inside the absolute value could be equal to what? So we are looking at this right there. So we have the absolute value of x equals 4. What could the value inside the absolute value be? Well, if you think back to the last slide, there were two numbers that had the absolute value of 3. There were two of them. It was positive 3 or negative 3. Well, in this case, there are two numbers that have an absolute value of 4, and those would be 4 and negative 4. So what could be equal to 4 or negative 4? X could be equal to 4 or negative 4. And that's a really simple equation there. So there's actually the two answers. Now let's apply that to something a little bit more interesting. So we have the absolute value of x plus 2 equals 4. So the good thing about definitions in math is that definitions do not change. We do not change their meaning. Once you know what something is, it's going to be that for good. You don't have to second guess it. So absolute value is distance from 0. And so here we have the absolute value of x plus 2 is equal to 4. Now we know from the problem right above it, there are two numbers that have an absolute value of 4. And those are negative 4 and 4, except now you have something different inside the absolute value. Now, instead of x being equal to negative 4 or 4, now it is x plus 2 could be equal to negative 4, or x plus 2 could be equal to 4. Now, if you're watching this at home, what I want you to do right now is pause the video really quickly and first of all, write this down, and then allow your brain a chance to process what you just wrote down and the reasoning behind it. Okay, hopefully you paused the video and thought through that again. What we've got there is something inside the absolute value, and the absolute value of that thing is equal to 4, which means that thing could be equal to negative 4 or 4. And then what we can do now is just solve each of these equations by subtracting 2. And so x could be equal to -4, or x could be equal to 2. And then what you can do is check that. So again, if you know what a solution is, you can go ahead and check it. So I'm going to go and plug in the -6. So we'll have -6 plus 2, absolute value is 4. -6 plus 2 is -4. And the absolute value of -4 is 4, which is true, which means that answer checks. And then I can do the exact same thing with the 2. 2 plus 2 is 4, and the absolute value of 4 is 4, which is true. And so I know that both of those solutions work because they meet the definition of a solution. A solution is a value of the variable that will make the equation true. So now you try some. Go back to the Explorer and see if you can solve the equations algebraically if you didn't do so the first time. So if you did solve them algebraically the first time, then go ahead and check your work and see if maybe you can clean up your work a little bit. So if your work is a little disorganized or it doesn't go from top to bottom very well, just try to clean it up. If you tried some other things, now try to solve them algebraically. When you've given yourself between 5 and 10 minutes to do that, unpause the video and come back and join us to go over them. All right, so let's take a look at them. We have the absolute value of m minus 4 equals 6. And I know that there are two numbers that have an absolute value of 6, and those are -6 and 6. Well, what must be equal to -6 or 6? The m minus 4. And so we end up with m minus 4 equals -6. Add 4. And we get m is equal to 2. And then we'll add 4 over here. And m is equal to 10. And we can do a quick little check on that. If I have 2, oh, wait a minute. That's a -2 right there. -2. There we go. And you know how I knew that? Because it wasn't going to check. So -2 minus 4 is -6. The absolute value of -6 is 6. Over here, 10 minus 4 is 6. And the absolute value of 6 is 6. And then the other equation, we have the absolute value of 2d equals 14. Well, there are two numbers that have an absolute value of 14. And those are -14 and +14. And what must be equal to -14 or +14? -2d, whatever was inside the absolute value. And then we can divide by -2. A negative divided by a negative is a positive. And over here, a positive divided by a negative is a negative. And we can do a quick check on that. -2 times +7 is -14. And absolute value of -14 is 14. -2 times -7 is +14. And the absolute value of +14 is 14. So we know that they check. Now, before you click on, reflect on your first attempts. Did you get the right answers on your first attempt? So were you successful? If you were successful, how does your strategy connect to the algebraic method? So maybe your strategy was, well, I guessed and then I knew algebraically what a solution was, so I was able to guess and then check. Or maybe you did a piece of the problem, but you missed another part. If you graphed it, what were you looking at? Can you see what you graphed in the setup here? And if not, if you did not get the right answers on your first attempt, what have you learned that could help you make better attempts in the future? Because we are not afraid of getting stuff wrong. Okay, we're not afraid of failed attempts, but what we want to see is a failed attempt is an opportunity to learn. So what have we gone over? How have we worked with a definition that could help you the next time I give you an Explorer like that, be able to get not necessarily get it right. I don't want to say that, but like make a better attempt or maybe a closer attempt. All right, so now let's explore a little bit more. What if something else is included in the equation? Okay, so now we have the absolute value of x plus 4 minus 3 is equal to 2. Okay, so now we don't just have the absolute value is equal to something. Now we have this minus 3. So on your own, think about what the expression in the absolute value must equal in order for the equation to be true. Because remember, when we're solving equations, that's what we're driving for. We're looking for the equation to be true. Okay, so I'm going to wait. I want you to think on that. All right, here's a hint. What minus 3 has to be equal to 2? So we have something minus 3 equals 2. So what does that expression need to be? Pause the video if you want to tinker with this a little bit, which would be awesome if you wanted to do that. Okay, so what I hope you've eventually come up with is you know that 5 minus 3 is equal to 2. And so that this quantity where my pointer is pointing over here, that has to be equal to 5. So whatever's in the absolute value is either 5 or negative 5. Okay, and that can give you that springboard for answering. Now, here's what it looks like algebraically. Okay, so what I wanted to drive home with that is that you've got to somehow deal with the minus 3. You can't have that minus 3 sitting over there. So algebraically, what we do, because I'm just going to give you another example. All right, so if you have x plus 7 equals 10, okay, I would hope that all of you could look at that and say, well, x has to be equal to 3 because 3 plus 7 equals 10. Okay, I hope that you know your addition facts well enough. But algebraically, what we would do if we were going to solve that is we would subtract 7 from both sides. And I know when I taught like pre-algebra and stuff, and I was really trying to drive home the importance of what are called inverse operations. So the idea that you take addition and you undo it with subtraction. And my 7th graders, 8th graders, whatever year that was, they did not want to do it because they could just look at it and see it. The thing is that it's not always that obvious. And so you do need to learn how to do an algebraic process. So even though you can probably reason out that x plus 4 has to be equal to 5, algebraically what we would do is we would add the 3 to both sides. And what that does is it turns it into the same kind of problem that we were just working on. So now we would ask, okay, what quantities have an absolute value of 5? Well, negative 5 and positive 5. What could be equal to negative 5? That would be whatever is inside the absolute value. And we would subtract 4 to undo that. So x is equal to negative 9. Or x is equal to 1. And you can do the same thing with checking your answer. So if you did negative 9 plus 4 is negative 5. The absolute value of negative 5 is 5, and 5 minus 3 is 2. If you had 1 plus 4 is 5. The absolute value of 5 is 5. 5 minus 3 is 2. Okay, and so the answer is check. So here's your key idea. Key ideas are important. If you're watching from home, make sure you pause here and write down the key idea because they're super important. The first step in solving an absolute value equation is to isolate the absolute value. So what does that mean? It means we must undo anything that is added, subtracted, or multiplied to the absolute value. Now, I could have said divided. You're just not going to see that very often, so I didn't bother writing it. But yes, divided also. Just it's not very common. Usually when you see stuff, it'll either be added, subtracted, or multiplied. If you see a division 1, just the same principles apply. So again, pause the video, make sure that you write this down. This is super, super, super important. And a quick clarification, isolate means get alone on one side of the equal sign, okay? One side of the equal sign there. Because and anytime I toss out a word, if you're thinking, okay, well, that's great, the first step is to isolate something, I don't know what that looks like, I don't know what that means. So always ask. All right, so let's look at a couple of additional examples. This just gives you a little bit more of an idea of what these problems can look like. So in this first example, we have 2 times the absolute value of x minus 3 equals 6. What you don't want to do is distribute the 2 through, okay? You don't want to distribute the 2 through because it only works half the time. So we don't want to do stuff that only works half the time. Now, what we can do though is notice that that is multiplication. And so you think to yourself, okay, how do I undo multiplication? Oh, that's right, with division. 2 divided by 2 is 1. 6 divided by 2 is 3. And then you start asking yourself, okay, what has that absolute value of 3? Oh, that's right, -3 and +3. What might be equal to -3 or +3? X minus 3. And so over here, we will add 3. And we'll get x is equal to 0. And here we'll add 3 and get x is equal to 6. And we can do a quick check. 0 minus 3 is -3. The absolute value of -3 is 3. 2 times 3 is 6. 6 is equal to 6. 6 minus 3, I'm checking the 6. 6 minus 3 is 3. The absolute value of 3 is 3. 2 times 3 is 6. Okay, pause the video from home to copy that down. Make sure you have that example written down because maybe I can. This is probably going to go horribly wrong. I was like, maybe I can use this space over here. I don't know. All right, so the next one we're going to see this problem later in the lesson also. Okay, so in this problem, here's the absolute value, okay? And then I have this stuff inside the absolute value, which is 2x minus 3. And then I have some stuff that's being done to the absolute value. So the absolute value is being multiplied by 4, and we're also adding a 1. Make sure that you undo that addition first. If you try to divide first, okay, first of all, you end up with fractions. And secondly, everybody forgets to divide the middle part, okay? And then you end up with these fractions, and because everyone loves fractions so much, it's everyone's favorite way to do it, except not at all, okay? Don't do that first. You can, but you don't want to, okay? Just trust me. First thing we want to do is subtract the 1, okay? And then 17, 1 minus 1 is 0, 17 minus 1 is 16. Now we can go ahead and divide by the 4, okay? And that gives us the absolute value of 2x minus 3 equals 4. And that brings us back to the previous kind of problem where we've got this thing inside the absolute value. The absolute value is equal to 4, which means that that thing inside is either -4 or +4. Adding 3, and I'm going to run out of space, so I'm not going to do the +3, and then divide by 2. Okay, and I'll say that again for those of you that are used to seeing it. When you see like +3, some teachers actually don't even want you to do that because they consider it just putting a lot of extra stuff into your work, and everybody knows that if you have the 3 + 3 is 6, so you don't need to write it. And so I actually don't care one way or the other. But from here to here, I added 3. So on the left, -3 + 3 canceled out, and then -4 + 3 was -1. And then from this line to this line right here, I divided both sides by 2. 2 divided by 2 is 1, and then -1 divided by 2 gives me -1/2. And I'll have to do the same thing on the other one. So I will add 3 and then divide by 2. And then you get a fraction and everybody freaks out because you're like, no! Fractions aren't great and they're harder to check, but I mean, they're actual numbers. so you can get them. Okay, pause the video here if you need to get those practice or those examples written down. And that brings us to your turn. So there is a problem there for you to practice on to see what happens, and then one for you to take a look at. So if you're doing this at home, I do want you to pause the video and try to do it out. Remember, we're not afraid of getting stuff wrong. So use the examples that I've showed you, go back to the content, rewind it, watch, hear that reasoning process again, see if you can apply it to the new problem if needed. If you feel confident, then go for it. And then do the one underneath it. All right. And then unpause it when you're ready and we'll look at it together. Okay. Hopefully that was enough time. So we have, remember that first step, that key idea. We need to get the absolute value all by itself. Okay. So that means I don't want that 3 and I don't want that 6. Those have to be moved out of the way before I can use the definition of absolute value. So we're going to follow good practice and we're going to start by adding 6. Okay, this one actually would be okay if you divided by 3 first, but that is a coincidence. And then we have, this is 3 times, so we're going to go ahead and divide. And we get the absolute value of x minus 4 is equal to 5. Well, we know that there are 2 numbers that will give us an absolute value of 5. So x minus 4 could be negative 5, or x minus 4 could be positive 5. And then adding 4, I would get x equals negative 1, and x is equal to 9. Alrighty. Okay, second one, take a look at this one. What happens when you try to solve this? What do you think this means? If you didn't do this the first time you pause the video, pause the video again and do it right now. And then we have some other questions I want to explore. What happens when you enter this into an equation solving website or app? You have permission to try it and see what happens. Be sure to think about what you did and what you see online. So pause the video and take some time to look at that next one. Right, so you might go onto autopilot a little bit, and you start with this, and you're like, okay, well, Miss Taylor said to isolate stuff, so I'm going to go ahead and subtract, and then we get x minus 1, and 3 minus 5 is negative 2. So now we come up to the question, what things have a distance of negative 2 from 0? And you should be coming up dry. You should be like, wait a minute, I thought that distances can only be positive. This is true. So what this might mean. So it says, what happens? What do you think this means? So you could come up with a lot of answers. What do you think this means? This is not an interactive video. So, but anyway, what you might think it means is that there is no solution to this. Now, then it says, find out what happens when you put it into an app. Okay, so I am pulling up, I don't know if you can see it, Photomath on my phone, and I am actually going to enter it in on Photomath right here. Okay, and what I am seeing is, I don't know if you guys can see that, but it says empty set. It's got like a circle with a line through it. Now, never, ever, ever copy stuff off that you don't know what they mean. Okay, so if you're using a website or an app to check your work, to whatever, and then you get some kind of symbol, okay, and it does this, okay, and you're like, I don't know what that means, then don't copy it down. Now, what you can do is send me an email. Miss Taylor, I was using Photomath to see if I could get some help on my homework, and it showed me this. What does this mean? Can you explain this in class? that is totally okay for you to do. Okay, I'm not going to get mad at you for using a resource to help you figure out your homework. What I will get upset about, though, is you copying stuff off that resource that you don't understand and then leading me to think that you understand stuff that you don't. Okay, so what that symbol means, that is the symbol for empty set. And we don't really talk about sets a whole lot in high school. We should, but we don't. And it means that there is no solution. It means that there are no number values that you could plug in for that variable that will make it true. Everything that you plug in to that will be false. Everything you plug in will be false. Okay, and so it's okay to get stuff wrong. It's okay to have the wrong idea, as long as you use that being wrong as a launch pad for understanding something deeper. And that's exactly what a math lesson is for. It's okay if you're wrong all the way through the math lesson, as long as every time you're wrong, you figure something out and can become right from that. All right. So let's take a look at inequalities. So inequalities, if you recall, are your less than, equal to, greater than or equal to. Now we say greater than or equal to. What that means, basically what you're looking at there is you're looking at the bottom of the equal sign. Sometimes I'm a little surprised that like nobody explains this to some of you guys back in like 4th grade. But I just bumped the cat with my arm. So you've got like your less than, and then what you're looking at is the bottom half of an equal sign. So less than or equal to. And what it means is, in order for it to be true, you will accept being equal. Okay. So for example, if you had 2 is less than 5, that's true. 5 is less than 5 is false. 5 cannot be less than itself. But if you put the little equal, then you say less than or equal to. So it means, okay, well, we will accept the equal to. So now it would be true because 5 is equal to 5. So that little equal to underneath means that you will accept equality as an answer. Okay, and if there's no equal to, it means you don't accept the equality. So consider this inequality. The absolute value of x plus 7 is less than or equal to 2. Knowing the definition of solution equips you to be able to check prospective answers. Let's divide up as a class and check some possible solutions. So what I intend to do in class, when I teach this in class, is I just realized the date was down there, so now you know when I'm recording this. All right. So what I am anticipating is I'm just going to divide the class up into groups and just assign people some variables. If you're doing this from home, I'll do a couple, okay? And then I want you to pick one on your own. Pause the video and pick one, okay? So I'm going to pick x equals -9, okay? So I'm going to plug in -9. And I get -9 plus 7 is -2. The absolute value of -2 is 2. And 2 is less than or equal to 2, which is true because of the equal to. Okay, so the equal to will work. And then I'll do x is equal to, I'll do the 4. Okay, so we'll do x is equal to 4. And so 4 plus 7, and that'll be the absolute value of 11. And absolute value of 11 is 11. And 11 is less than or equal to 2. That is false. Okay, now if you're at home, I don't expect you to check all of these unless you really feel like doing it. But I do want you to pause the video and check at least one of them. Okay, just to work through what that process is and what it looks like. Okay, so pause the video and check that out. Okay, now I am going to erase my work here. So pause the video, make sure you've copied it down if you want it, because I am going to erase it momentarily. Turns out that I have some animation on this slide that I did not know I had. Okay. So it says check answers like this. That should say checking. Typos. Answers like this is tedious, but can reveal patterns that can often lead us to answers. So even though this is a little bit boring and you might feel like you're not getting anywhere with it, it's valuable in that sometimes you can stumble across some patterns and that can help you figure stuff out. So here is what you should have come up with, depending on what you picked. -10 was false. -9 was true. -6 is true. And then 0 is false and 6 is false. So what you should notice is like we have this little chunk of trues that are kind of back to back. Now, if you're curious, you can pick like, well, what about something in between? What about -7? What about -8? What about -6.5? Okay, don't forget decimals. We don't like to pick them. What about a -5? Like, does a -5 work? And so I do want to draw your attention to that there. So let's go through how this looks algebraically. All right. So I'm going to bring you back to the definition of absolute value. Absolute value is the distance from 0. So let's go slap our number line on here. And we'll put the 0. Okay, and we have -1, -2, -3, 1, 2, and 3. So what this is saying is that the distance from 0 is less than or equal to 2. Where on the number line would you see something where the distance from 0 is less than or equal to 2? Well, that number has a distance less than 2. So does this. It says less than or equal to 2. So that would work. And then everything in between, like 1/2, the distance is less than 2. -1/2, the distance is less than 2. And what you've got here is basically all of the numbers in there, in between -2 and 2. So x plus 7 has to be wedged in between -2 and 2. So the way we would do this is we would say -2 is less than or equal to x plus 7 is less than or equal to 2. And then this is what's called a compound inequality. All right, compound inequality. And it works the same way as an equation where you have to do the same thing to both sides, except like here you have 3 sides to it. So if you're going to subtract 7 to get the x by itself, you have to make sure you subtract 7 from the left and from the right. You just have to subtract it from everywhere to make sure that you're not throwing off your inequality. So -2 minus 7 is -7, or -9. 7 minus 7 is 0, isolates the x, and 2 minus 7 is -5. Now, the question there is, does this answer match what we saw on the previous slide? On the previous slide, remember that we had -10 did not work, -9 did work, -6 worked, and then I don't remember where we went, like 0 did not work. And so if we look at what we got on the other slide, the ones that worked were inside that band. They were between the -9 and the -6. So that's what it looks like algebraically. Now, what I will try to do is I do have some videos that go into a lot more depth with absolute value inequalities, including the greater than inequalities that might be worth checking out. So I'm going to link that in a card right here. I hope I got it. It's 4404. Okay. I'm gonna make sure that I link the card there. So it should be there for you. All right. Now, Desmos can solve these for you, which is super, super useful and probably the direction that we want to go in. So what I am going to do on this is I hope I am going to do the same one that we just did, and I will show you how that works. Okay, so here we have the Desmos calculator, and what I'm going to put in is the absolute value. I'm going to actually put in the inequality that we just did. So the absolute value of x plus 7, and then I'll have to do a right click to get out, and then we were doing is less than or equal to 2. Okay, now I'm going to minimize that and so that you can see. I think I can turn. No, I don't think I want to mess with that. Just follow. I don't know if you can see my pointer though. Laser pointer. All right. So what we have here, now this is in 2 dimensions. Okay, this is in 2 dimensions because we're graphing on the coordinate plane instead of on a number line. But what I want you to do is just ignore everything except the x-axis. And if you look closely at the x-axis, we have -1, -2, -3, -4, -5, -6, -7, -8, -9. And everything that is shaded in between are the things that work. So if you were to write this out, you'd have -9 and -5, and x could be everything in between. Now notice those solid lines here, okay? That corresponds to like the filled in circles on your number line, meaning that we are including that. Okay, so that's actually a pretty cool way to do that. I'm going to look at a couple more examples on Desmos. So we're going to look at a couple more of these, and I've got to turn off the pen. I'm getting better at this, like how to access the Desmos inside the PowerPoint. So we're going to look at the absolute value of c minus 1. I think with Desmos, well, I don't actually remember. If I do c minus 1, I think it might yell at us with the c. It does. Okay, notice that like it's yelling at us. Well, not yelling at us, but it's saying add slider. That's because Desmos is working on the XY plane and it's not recognizing the variable c. So to do this, if you have a different variable, you just need to change it to an x, and then we're good. And then we're good. Then we can see everything. So let's take a look at this. Now remember, we're only going to be looking at the x-axis. Now what you should notice about this is that there's actually 2 regions here, okay? 2 different regions. So we're going to have 2 different expressions. So our x could be over here or over here. In the first one, x is less than or equal to, because remember you're going left, which is less than, and that's going to be at -4. Or x, and we have to come over here, that's greater than or equal to, what is it? Greater than or equal to 6. Okay? I'll let you kind of think that through. Now, I can do additional examples. So the greater than, the way it shows up is you think about the distance is greater than something, like from 0. So, distance greater, notice that you go greater distance this way and greater distance, and then this is your less distance. Again, that other video that I linked in, and I might even put it at the end of the video also, we'll go into a lot more detail with that. All right, let me erase this because I don't want that all over my slide. There's like a little, there we go. And then I have to turn all this off. And let's do the other one. Now, this is one that I solved by hand earlier. So this was one of our example problems by hand. 2x minus 3. And then we'll do plus 1. And this one just has is greater than. It does not have the or equal to. And then let's take a look at that. So what you might notice right away is that you have dashed lines here, and dashed lines are the equivalent of the open circle. And what that means is that the endpoint is not included. Okay, so it means that it's less, it's in this case greater than. And I can't see exactly where that is. This is, I think, well, 7/2 is like 3.5. I'm just, where's my pointer? What would be great is if I still had that other, 16 plus 3, 19 divided by, you know what, never mind. Oh, it's 8. Oh, wait a minute. Did I? Oh, I put it in wrong. That's why my answers don't make sense, or why they don't match from before. Hang on. Some of you at home are probably like, Miss Taylor, that's not right. I put in a 7, and it was supposed to have been a 17. There we go. That looks better. So last time it was what, like -1/2 and 3.5? That's what I think we got there. Okay, so like that looks better. So -1/2, and then this should be 1, 2, 3.5. Okay, now before, when we had the equal sign there, that should be 17 on that slide. That's why I'm looking at my notebook to the side of me. And we got x is equal to -1/2 and x is equal to 7/2, which is 3.5. Okay. Now we've got the inequality, and so now we would have x is less than -1/2 or x is greater than 7/2. And you do need to say or, because x cannot be in both places. Okay, x cannot be in both places. It was a little bit bumpier than I think I had hoped it would be, but what are you gonna do? Where is my... Okay, and now finally this last one. I think this is the last slide. Maybe there's one more. I'm not sure. So I want you to do this one. You can do it out by hand, or you can do it out on Desmos, but pause the video and see what you can do with it. Right. Now I don't have Desmos embedded in this slide, so I am going to do it out by hand. So the distance from 0 has to be less than 8. So I'm going to come over here and just kind of do a quick graph of that. So less than 8 means it's closer than 8, but not equal to 8. So we want to make sure we keep that open. So that means that x plus 3 has to be wedged in between -8 and 8. And then I'll subtract 3. I got to make sure I subtract 3 from both sides. And I get -11 is less than, x is less than 5. Now on the Desmos graph, it'll look something like this, where you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 3, 4, 5. It'll be looking like this, and it'll be shaded in the middle. Okay, so it'll look something like that. Now I do have a video also that it just kind of reviews how to do this on Desmos. So if you would like to check that video out, I will link that one also. But I think that is it for this lesson. I'm going to click on the next slide. But if that is the last slide, then I hope that this helped and that you